What's up, everyone? Today we're going to be going over Leetcode 1034, color border. Now this is a pretty involved problem, at least the way I solved it, and there's a few arrays and a few helper methods that we're going to use, but pretty much what they want us to do is find everything which is in a border from the given coordinate and color it with this. Now there's a couple conditions. One is that if it's surrounded by the same thing and it's not on a border, it has to remain the same. But if this connected component is on a border, you have to change it to this color. So let me first take care of the basic data structures and methods that we need to do. For example, moving up, down, left, right on a 2D grid, making sure that it's within bounds. So both of them are going to be, it's going to be x, y, and then border. And then I make use of two Boolean arrays called vis and in border. The way I solved it is first I change everything, including the middle, and then I change this one back to the original. And I do that correctly by making sure that I know which ones are the ones that are supposed to remain untouched. So int x is going to look like this. Okay, go up and go down. Same. Y is going to be here, then go back and go forward, and then outside is going to be a helper method, which pretty much says, hey, am I within the bounds of the grid or not? If it's outside, I'm going to return true. Return true. Not like that. If I is less than 0 or I is greater than or equal to grid.length, or j is less than 0 or j is greater than or equal to grid of 0.length, you return true, else you return false. That's the helper. That's this guy, and this guy's done. Now visited and in border are pretty much going to be the same dimensions as the input grid. The visited 2D array, we all know how it works. And it's just to keep track if we've stepped into it. So I'm just going to write it out. Boolean vis is new Boolean m and n, assuming m and n are the dimensions of grid. And my helper, other one that I use, I call in border, which pretty much means inside border, is going to be true if a given number is in between all four sides of the same number, but it's going to exclude the number of the borders. So my in border for this question would look like false, 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 true, false, 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 false. Because I kept track of this true, I know that after I change everything, I'm going to put this one back into a 1 where it belongs. So my DFS pretty much changes everything to a 2, and then it'll undo what it did incorrectly. So my in border is done. Now we have to write a method called border, because the problem definition says if something is on the border and it's the same color as the original and in a connected component, we need to set it. So Boolean border int grid int I int j if I is equal to 0 or I is equal to grid dot length, or j is equal to 0 or j is equal to grid of 0 dot length, we return true, else we return false. That's going to be this method. And then the last one, I make use of a helper method called forSide, which pretty much says, hey, is there any number on my up, down, left, right which is different than me. If it is, then return true. Boolean for side, int grid, int I, int j, int color. I have a Boolean res, which is false, and then for int I is equal to 0, I is less than k. K is less than x dot length. The x is a global variable. X and y are global variables because we're going to be using up, down, left, right in several methods of the code. And then int row is going to be I plus x of k, and then int co is going to be j plus x of y of k. If row and co are not outside, now keep in mind, outside is the helper method we wrote already. If it's not outside row and co, then we can check if it's not outside and grid of row and co is not the same as the color that's passed in, then we can say, well, I'll call this outer for loop, just loop, outer for, loop, and then we can say grid, no. If they're different, then I say res is going to be true, and then I can break the loop. And then I return res. So that's our for-side function. Pretty much I'm going to use it to make sure that it is to check if something is different on any of the given sides for one square. Now, let's get into it. The first thing I'm going to do, I'm going to assume these guys are already initialized. And the first thing I'm going to do is I'm going to populate my in border. So that's going to be for int I is equal to 1, I is less than m, comma I plus plus. For int j is going to be 1, j is less than n, where m and n are the size of grid, j plus plus. If we are not different on any of the four sides, and I, comma j, and the original, so int ori is going to be the original number that's given at this coordinate on grid, r0, c0, and ori is what we care about, because we only care about the function that we're starting off the recursive stack in. This is going to say for side is set to true. Now my for side is going to be initialized like a false, 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 true, false, 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 false. So once my DFS is done, I'm going to check how many ever trues are there. They're going to be all put back to ORI, which is the original number in the grid of R0, C0. Now that that guy's done, I can call my DFS of grid, R0, C0. Yeah, R0, C0, color, and ORI. I'm going to get into the DFS in just a second, but let me just finish up this main color border method. Then I will do for int I is equal to 0, I is less than m, I plus plus, for int j is equal to 0, j is less than m, j plus plus. What happens here is if in border, if it's true, then I'm going to set grid ij to be ori, the original untouched. That's the if loop, inner for loop, outer for loop, and I'm going to return grid. Now hold on, we're not done yet. We have the main meat, the DFS. I'll show you how that works. So what my code so far is assuming is that I keep track of what I need to put back originally, because my DFS is going to change everything in the connected component. Then I go back and keep track of what needs to be undone. I undo it for grid, and then I return grid. Let's look at DFS. Okay, so DFS is going to be a void, so we don't have to write a return value. We take int grid and int r0. We can write I, int j, int color, and int ori. Now we know that if we visited I and j, or grid, or if we're outside. Actually, let's do that first. If we are outside, otherwise we'll get an out of bounds exception. If we're outside of the bounds of the grid, or if we've visited it already, or this coordinate doesn't have ORI, which is the original, so we don't care about it. If it's not equal, then we can just return. Now, we took care of every single base case where we are not going to explore any further. Now let's see what we will explore for. If we're on the border, grid ij, and grid of I and j is the original, then I'm going to set the visited I and j to be true, and I'm going to set the grid color to the color that's passed in here. Now there's another case where we have to change the color, is if there's at least one side which is a different color than the one that's passed in. I think foresight is going to take in ORI. Yeah, it's going to take in ORI, and if grid of this guy is ORI, which is the color we care about, then the same thing, we set it as visited, and we set this guy to be color. Now that we wrote the meat of the DFS with all the logic, all we have to do is recursively call it for up, down, left, right, while making sure that our coordinate is inside the bounds. So I'll erase this. Now the DFS, the last part is just going to be the same thing that we're used to in so many recursive functions. X.length k++ for int row is going to be I plus x of k, and int co is going to be j plus y of k. If it's not outside the grid for a coordinate row and co, then we recursively call for grid row co, color, and ORI. That's the if loop, that's the for loop. So that's how I solved Leetcode 1034. It's pretty in-depth and there's a lot of moving pieces, but if you look at the code below, you'll see that it all makes sense and it's good practice. If you like the video, please subscribe, and yeah, keep watching. Thanks.